Good morning, welcome back. Now today we'll see, this is the second session of types of energy. We already saw about the definitions and formulae for kinetic energy and potential energy. Today we'll see about, there is a law. What do you mean by law? Law means it is true under any circumstances or conditions. Now it says the law of conservation of energy. Okay, we'll see what is a conservation of energy and how it can be applied to real life situation to find out either the velocity of a object with which it will hit the floor, or from what height it had been dropped, and so on. All right. Now, when you say conservation, that means there is no wastage of energy. Okay. Conservation term stands for no wastage. Conservation of energy means there is no waste of energy. Now, for simplicity here, we'll take an isolated condition. Okay, because we don't want any other factors influencing the movement of the object. So hence we'll ignore air resistance or friction, etc. Other forces are ignored in this statement. So in an isolated system, the total mechanical energy is conserved. Okay, or you can say the total energy will always be the same. Okay. All right. Now, consider an object from a height h is dropped, all right, through the height, and it hits the floor. Now here, what types of energies are associated? Now, when the object is at this point, okay, at the maximum height, it is at rest, so it will possess only GPE. Okay, gravitational potential energy. So the GPE is maximum here, right? Now, what will happen to the GPE as it falls? It gets converted to kinetic energy. Okay, that GPE is used up and it gets converted to kinetic energy. Now, what will be the kinetic energy at this point when it is at rest? We know the speed will be 0. If there is no movement, then kinetic energy at this point will be 0 joules. Now, when it falls through the height, as we said, Ke will increase, GPE will decrease, and as it hits the floor, what will happen here at this point, the height becomes 0, correct? The height becomes 0. So what will happen to GPE? GPE here will be 0, but Ke will be maximum, right? So this point you need to remember these two extreme positions of the object. At the maximum height when it is at rest, GPE is the maximum. You can calculate by using the formula. Kinetic energy is 0. When it hits the floor, GPE becomes 0. Kinetic energy is maximum. We will plug in some values and proceed with the calculation. So GPE, say for example, if the object is 1 kg mass, okay, formula is mgh. So I put here 1 as its mass, multiplied by G is 10, height, say we take it as 10, so it will be 100 joules, correct? So this GPE maximum here will be equal to 100 joules. Kinetic energy is 0. Now, law of conservation of energy states that the total energy possessed by the object is going to be the same, or it is conserved. There is no wastage of energy. Now, since here we have considered as isolated system, we are ignoring air resistance and friction, right? In that case, this 100 joules of energy should be the same throughout the journey of the object, correct? Now, say if I take it halfway through, okay, half the distance, that's like, this is 10 meters I have taken, say 5 meters height, what would be the kinetic energy and GPE here? GPE would have decreased by half, so GPE will be 50 joules. Kinetic energy would have increased, right, by the same amount that it has been lost, so it is 50 joules, and this together should be 100, right? Now coming to this position, now GPE is 0 here, so what should be the kinetic energy maximum? Ke will be equal to 100 joules of energy. So this point you have to remember. Now, say in this question, they've asked you, the values that are given to you are the height, the mass of the object are given, and they've asked you to find out what is the velocity with which the object hits the ground. Okay, what is the velocity with which the object will hit the ground? How do you find out? Now, GPE we have calculated 100 joules. Now, with this we know that it is equal to kinetic energy. So, KE is also equal to 100 joules, right? As we said, if it is conserved, no other forces are acting on it, then kinetic energy is 100. Now, from this, will I be in a position to find out velocity? Yes, I can, because kinetic energy formula I can write half mv square is equal to 100, right? So, I bring this here. So, mv square will be equal to 200. Since m is 1, v square is 200. So, v will be equal to square root of 200. Okay, you get the value, and that will be in meters per seconds. Now, this velocity is actually the maximum velocity with which the object will hit the ground. Clear? So, this is how the theory works, okay, the exchange of kinetic energy and GPE in a falling object from rest. Clear? Now, here I will give you a shortcut for those of you who are interested. Right. Say if the same question is given, and so I will write down what I will given: 1 kg, height is equal to 10 meters, V max is the question. Now, by theory, GPE maximum is equal to kinetic energy maximum, right? So, I can write it as GPE max equals kinetic energy max. This is for extended students. Some of you, if you think this is confusing, you don't have to go through this. Just stop it from the previous calculation. You could proceed and do the same for any calculation, but this will be handy when you are, if you want to save time. Now, half mv, this is maximum square, kinetic energy maximum, because through this there will be kinetic energy, it increases, and the maximum is at this point. So, we are equating kinetic energy maximum and GPE maximum, all right. And if you see m is common, so I can eliminate m. Okay. Now, I will bring this 2 here to this side, so it becomes 2 GH will be equal to V max square, or if I take V max will be equal to square root of 2 GH. Now, this is the formula that will help you to calculate the maximum. So, if you look at the formula, it only has gravity and height. You don't even need to know the mass of the object. So, if you drop an object from the same height, okay, no matter what the mass of the object is, all of them will hit the floor with the same velocity. Now, how do you get that velocity, the maximum velocity? You just have to square root 2 times gravity, that's 10, times the height from where it is dropped. So, you can skip all these calculations. You just need to take the height and gravity and get it in one step. You can get the answer. So, here you will get square root of 2 into 10 square root of 200. You will get the same answer. Clear? I hope it's somewhat clear. I'll give you some questions related to this for you to solve, and try to solve more questions from past papers once you have watched this video, to get a hang of how to approach the question. Because if you save some time in figuring out the quantities and the formula, the method, then you'll be in a better position to complete the paper and recheck the entire paper. All the best, and see you in the next video.